240 watts through a cable Anker 543, the width of your finger. That's basically wall outlet territory. And today we're finding out if this thing can actually back it up. Open packaging, and it's no frills. The cable itself, a manual, a couple of info leaflets, that's it. Here's a small detail the EDC folks are going to appreciate though. There's a soft silicone cable tie built right into the cord. Now, build quality. The connectors themselves feel solid and a little hefty. Anker logo debossed on one end, bio-base stamped on the other. That bio-base claim means part of the housing's made from plant-derived material. Marketing angle or not, the cable itself feels genuinely nice. There's also a flexible strain relief boot at each end that bends with the cable instead of fighting it, which helps protect the wiring from sharp angle stress over time. All right, the part we actually care about. Plug it into the hardware tester and the eMarker chip checks out fine. It correctly reports itself as a passive cable rated for the full 240 watts, 48 volts at 5 amps under PD 3.1. Handshakes were clean across every power source we tried. No weird negotiation issues. But here's the number that actually matters, internal resistance. We measured this 6-foot cord at 119 milliams. For a cable this long, that's impressive. Lower resistance means less power wasted as heat, which translates to better efficiency, especially once you're pushing real wattage through it. We ran a full hour of continuous load at 140 watts under a thermal camera. The connector topped out at 109 degrees Fahrenheit, that's 43 degrees Celsius. The cable body itself stayed even cooler, around 80 degrees Fahrenheit or 27 Celsius. And the heat spread evenly across the whole length, which is a good sign. It usually means clean solder joints and no weak spots inside. Okay, now here's the catch I mentioned earlier. And depending on what you use cables for, this might actually be a deal breaker. This cable is an absolute beast for charging. For data transfer, in our actual transfer tests, it landed around 37 to 38 megabytes per second, both reading and writing. So if your plan is hooking up an external SSD or pulling 4K footage off a drive, this cable is the wrong tool entirely. You'd want a proper USB 4 or Thunderbolt 4 cable for that. Completely different category. Where does this actually leave us? Let's run through what the bench numbers actually told us. On protocols, this is really the whole story in one line. Full power, capped data. PD 3.1 EPR gives you everything on the charging side. USB 2.0 holds you back on everything else. On power delivery, 240 watts, 48 volts, 5 amps, all confirmed, no asterisks. The eMarker doesn't lie, and neither did this cable. On resistance, 119 milliams. Not the absolute lowest number you'll ever see, but genuinely strong, especially once you remember how much copper it takes to push real wattage through a cord this long. 43 degrees Celsius at the connector, 27 at the cable body after a full hour at 140 watts. That's about as boring, in the best way, as a thermal test gets. So here's the bottom line. This is a purpose-built charging cable. It does one job, and it does it really well. Stable power delivery, low heat, solid resistance for the length. The trade-off, and it's the only real one, is data speed. You're not moving files fast through this thing, full stop. If what you need is something to reliably feed a power-hungry laptop or tablet, this earns its spot in the bag. If you also need it to double as a transfer cable, that's where it lets you down. Hit subscribe if this saved you from grabbing the wrong cable, and I'll catch you in the next one.